You invest money, the value of your investment A, in hundreds of dollars after T years is represented by the following equation. What does 3.2 mean? Remember, just like we've done, this is your initial amount and this is your rate. This is your rate, this is your initial amount. So 3.2, what does that mean? $3.20? It's your initial, but it has to be in hundreds of dollars. So it's your initial amount invested in hundreds of dollars. Correct answer is D. If somebody would ask what is 1.06, it's your rate. It's your annual rate, okay? So does this tell us that the amount of money you invested is growing or is it decreasing? How do you know that? It's greater than 100%. Remember, 100% is like 1.00. So in fact, this appears to be growing at 6% annually. Let's move down right now to number 13. The population of a town is currently 6,000 people. So A sub 1 is 6,000. It's expected to triple every 5 years. So your rate is tripling. I'm going to represent that with a 3, and I need to know that happens about every 5 years. How many people can we expect to be living in the town in 25 years? Okay, so we have our boxes. Our initial amount is 6,000. Our rate, represented by a 3, it triples every 5 years. How often that occurs goes in the bottom. Now we want to evaluate this to find out after 25 years. So we're going to do PEMDAS here, which means we're first going to take care of the exponents before we multiply. So 3 raised 2, and you could put in parentheses 25 divided by 5, but we know that's 5. So 3 raised to the 5th times the 6,000 out front, which is the initial value, and that tells us we could expect to have 1,458,000 residents in this town in 25 years if it continues to grow at the same rate. Please highlight or star the problems that we have just completed and turn your paper over to the back side. This is Newton's law of cooling. And here's what Newton's law of cooling tells us. Let's pretend this is warm soup. Okay, everybody look up here. This is warm soup. I know we see a bottle of water, but we're going to pretend it's warm soup. Now, what impacts in this bottle, what impacts this warm soup staying warm? Yes, there's to do with insulation. But would you agree that if it was in July, this is going to stay a lot warmer than if it's in January? Why is that? It's the air outside of the container. So Newton's law talks about cooling or heating up, and the context of what the liquid we're talking about and the rate at which it cools or it heats up it depends on the outside air that's surrounding it. So here's our basic formula we're going to use, and it tells us what each one of these stands for. And it says you are driving on a hot day when your car overheats and stops running. It overheats at this temperature. This is your initial temperature that it overheats at. It overheats at 280 degrees Fahrenheit and driven again at 230 degrees Fahrenheit. This is your rate. This is your R. And it's 80 degrees outside. How long in minutes do you have to wait until you continue driving? So what this is saying is, okay, right now it's overheated, your car, it's 280. Now we can drive it again when it goes down to 230. Currently, this is what it is. Your car is at 280 degrees Fahrenheit, the engine. We can drive the car again when it decreases down to 230. And the outside air is 80 degrees. I want you to read up here to represent what each one of these different symbols represents, and I want you to come up with just the equation. We'll do the rest together. Begin with your partner right now. So the temperature we want the car to reach so it can begin working again is determined by taking the initial temperature, subtract what the outside air is. We're going to take that times E. Remember, E is a number raised to this rate plus this outside temperature. Now, how do we solve this for E? With your partner, you do the best you can. Do the best you can, and we're going to round our answer to the nearest minute. I'm going to give you a 30-second head start before I stop you. Okay, so to do that, I take 280, subtract 80, and I end up with 200. And I'm following the PEMDAS rules. All right, so PEMDAS says, please excuse my dear Aunt Sally. So I've worked to this part. Now, is there any adding or subtracting on the side that has the exponent? We're going to get rid of the 80 by subtracting it from both sides. What is 230 subtract 80? Anybody, can you help me out, please, real quick? So I'm going to have forgot a 0 there. So I'm going to have 150, thank you, Sam, equals 200 times this quantity. Please divide by 200. If it turns into a nice decimal, great. And if not, we'll just reduce the fraction. And we're going to see that it is a nice decimal. Some of you can just do this in your head. We get 0.75. So the left-hand side is 0.75 equals E raised to the negative 0.0048t. Why do we learn logs? There's a purpose. Why do we have to learn logs? To solve for a variable in the exponent. So we want to get rid of this E so that we can solve for t. So I'm going to do the log base E to both sides. Log base E to both sides. And then I write down what was already there. The E's cancel, and remember, in reality, they don't just disappear. They turn into a 1. And I bring down this amount. And now, there's nothing wrong with this, but do you remember on your calculator, there's another button that represents log base E. It's the only log that has like its special button. It is ln. So let's write ln of 0.75. So I can achieve this answer using a calculator, and then I can divide to isolate the t. So let's grab the calculator and let's type in ln of 0.75. Make sure to press enter, and then let's divide by the decimal negative 0.0048. And the directions say to round our answer to the nearest minute. So round it to the nearest minute would be how many minutes? It would be approximately 60 minutes. So it would take, let's make sense of this answer. It would take approximately 1 hour or 60 minutes for your car to go from 280 degrees down to 230 degrees so you could drive it once again if the air outside is 80 degrees and we're using this rate. Thumbs up or thumbs down right now? Okay, that's what the Newton's law of cooling is talking about. Okay, flip and find the next Newton's law of cooling, which is going to be, can you guys find it? Number 19. So the first thing I do is I explain what Newton's law of cooling is. Have one person in your group please read this out loud, and then I want you to come up with your answer, and I want you to compare it to the answers you see. Okay? I'm going to give you 2 minutes. Ready? Begin. say the temperature you want to achieve of coffee is 155 degrees. Your initial temperature is 180, and the outside temperature is 76. Your rate is 5, so negative 5T. Plus, this is the outside air, 76. So I'm going to start by subtracting 76 to both sides. And 155 subtract 76 is 79. Okay, and 180 subtract 76 is 104. And divide by 104, divide by 104. So I have 79 over 104 equals e raised to negative 5t. The purpose, once again, of learning logs is to solve for a variable that's in the exponent position. So I'm going to do, we want to get rid of the number e. So I'm going to take log base e to both sides. And I'm going to do it over to the side here. It gives me a little extra room. Log base e and log base e. And then I'm going to write everything that already existed here. 79 over 104 and e raised to the negative 5t. On the right hand side, these cancel. In reality, they turn into a 1. And I bring down the negative 5t. And remember, although this isn't wrong, another way, even easier way, to use your calculator to do the log base e of this quantity is to do the ln of 79 over 104. Okay, and my last step is going to be to divide by negative 5. Hey, stop for a second. How many of you were able to get to at least this part right here? At least this part, hands up high. Now this is where it's just a little bit confusing. By the way, do we see any more e's in our answer? At this point, are there any e's? So anything that has an e, let's cross out. Okay, down to 4 choices. So yes, just dividing this quantity by negative 5 is not wrong, but you don't see that as one of your options. Well, it is, but it's in another form. Remember, dividing by this number is the same as multiplying by the reciprocal. So I can multiply by negative 1/5. I can multiply by negative 1/5 to isolate the t, and that's the same thing as just dividing by 5. So do I have a negative 1/5 out front? Okay, that's option B or C. I need the ln of 79 over 1 over 4. Okay, so which one is correct? It is option B. Option B.